let's take a look at the first lesson of the new unit. We are going to look at a concept called a matrix. So of course, let's start with some definitions. What is the definition of a matrix? A matrix is an arrangement of numbers into rows and columns with a large set of brackets around the arrangement. And they are named using capital letters. Okay, so we're dealing with numbers, positive, negative, decimals, fractions. They're in rows and columns, very nicely organized. There's one large set of brackets around the outside, and we name them with a capital A. Now, one important aspect of a matrix that is very helpful to us in terms of some later topics are the dimensions of it. Okay, the dimensions are simply the size of the matrix, written in this form. M by N, that's not X, and it's not times, we call it by. So it is M by N. M is the number of rows, and rows go horizontally, and N is the number of columns, and columns go vertically. So you count how many rows there are, and that's the first number, and you count how many columns there are, and that's the second number. So let's take a look at an example of that. For these three problems, we are simply asked to state the dimensions. So again, we need rows first by columns. Rows go horizontally, so there are 1, 2 rows. Columns go vertically, there are 1, 2, 3 columns. Let's try another one. There are 1 row and 1, 2, 3 columns. I know it's kind of weird to see a column with only one number in it, but they are columns. And finally, this one, we have 1, 2 rows and 1, 2 columns. So hopefully that's pretty easy to you, and that is something, again, that we are going to be using in several of our lessons. New vocab word. What is a matrix element? A matrix element is an individual item in the matrix. The notation that you will see asking for a matrix element is a capital letter naming the matrix, then a 2-digit subscript. Subscripts are little numbers down below, and they name first the row and then the column, like the dimensions. So for example, A21. This is looking for the item in the second row, first column. So let's take a look at applying this concept. We have a matrix here. It is named matrix K. Any capital letter can be used to name a matrix. So our first item is looking for K12. This is the row, and this is the column. So we need the first row, which is up here, and we need the second column. So first column, second column. So that answer is -1. And that's all you have to do. K32. We need the third row, second column. So first row, second row, third row, first column, second column. We're looking at -4. K23, second row, third column. First row, there's the second row, 1, 2, 3. So this is 4. And finally, K34, third row, fourth column, 1, 2, third row, 1, 2, 3, fourth column is -5. Pretty easy, right? So far, all we're talking about is some vocab. So let's look at an application problem. There are 3 students who kept track of the games that they won and lost in a chess competition. They showed their results in a chart. So as you can see, we have Ed, Joe, and Lou. Check marks mean a win, X means a loss. We need to write a 2 by 3 matrix to show the data. So 2 by 3 means 2 rows, 3 columns. So what that would look like, here's one row, there's another row, there's your second column, there's your third column. That's how we are organizing our data. Now, when you are taking data and putting it into a matrix, labels are important. So here's our options. We have 3 names that we are going to label, Ed, Joe, and Lou, and we have win and loss. So hopefully you're thinking right now, well, there's only 2 options here, and there are 3 options here. This is going to be your wins and your losses. This is going to be Ed, Joe, and Lou. So Ed had how many wins? 1, 2, 3, 4, 5 wins and 1, 2 losses. Joe had 1, 2, 3, 4, 5, 6 wins and 1 loss. Lou had 1, 2, 3 wins and 1, 2, 3, 4 losses. That is how you take raw data and organize it into a matrix. Let's look at another problem similar to this. You have a graph here that talks about the days lost to strikes. So as you can see, we have 1985 to 1989 and 1990 to 1994. We have 3 countries, Greece, Canada, and the United States. So blue is Greece, red is Canada, and green is the United States. Write a matrix M to represent the data with columns representing the years. So your columns are your years. So if this is my matrix, I'm going to put the columns as the years. So the first pair is 85 to 89, and the second grouping is 90 to 94. Well, then we have, obviously the other labels are our countries. So we have Greece, Canada, and the United States. So let's pull our data. So 85 to 89, that's this group of bars. Greece is up here at, in between 1800 and 2000 is 1900. Canada is dead on at 400. And the US is right in the middle of 0 and 200, which is 100. Let's now go over to this group of bars. Greece is at 1400. Canada is at 200. The US, this bar is even lower than the old bar. So I'm going to say if the old bar was 100, I'm going to say that bar is 50. And yes, if you have to approximate, perfectly fine. So what are the dimensions of this matrix? Well, there is 1, 2, 3 rows and 1, 2 columns. And they want you to find M32. So 1, 2, third row, 1, 2, second column is 50. So hopefully you're thinking so far, wow, that's really, really easy. The only other thing that we're going to talk about today is how to add, subtract, and some very easy multiplying. So let's look at some rules. When you are adding matrices, first important rule, they must have the same dimensions. In other words, they must be the same size. And then all you have to do is add the elements that are in the same position. Pretty easy. Subtracting. Also, must have the same dimensions, in other words, same size. And instead of adding, we're going to subtract the elements that are in the same position. However, I did make one little note, and this is an important note. Be careful with your negatives, because subtracting a negative is very different. And finally, this is the easy multiplying. We're going to spend an entire next lesson on regular multiplying. This is the easy kind. This is multiplying by what's called a scalar. Multiplying by a scalar, what you will see is you will see a whole number in front of your matrix. All you have to do is multiply each element by that number in front of the matrix. Most students think of this as distributing, and that's exactly what it is. You're distributing a number to the entire matrix. So let's look at some examples. We are either going to add, subtract, or use scalar multiplication. So this first problem, this is an addition problem. Are they the same size? Yes, they are. So all we're going to do is add same spot with same spot. 0 plus 1 is 1. 4 plus -9, see what I mean with negatives? That is a -5. If you're not good with negatives, use your calculators. 3 plus 8 is 11. Let's look at B. Are these the same size? Yes, they are. This is now subtraction. So let's be careful. 7 take away 2 is 5. 8 take away 0 is 8. Here's where we're going to have some mistakes. In your calculator, -9 minus -3. You should get, if you did it correctly, -6. And then also 0 take away 5 is -5. Now a lot of students ask, are those brackets that I keep drawing a requirement? Yes, absolutely. If you leave those off on a test, you would lose points. Now let's look at C. What do you notice about C? Well, you do see that it's an addition problem. However, we have a 2 here. That's an example of a scalar. Okay, we're going to distribute. And of course, in math, what comes first, multiplying or adding? Well, multiplying does. So we're going to multiply 2 to every single number. So it now looks like 2 times 6 is 12. 2 times -2 is -4. 2 times 6 is again 12. And 2 times 3 is 6. Then keep that second matrix because we're not done with it. And now what kind of problem is it? Well, now, again, it's an addition problem. Add your positions. 12 plus -3 is 9. -4 plus +4 is 0. 12 plus 1 is 13. And 6 plus -7 is -1. What do we think about adding and subtracting? Pretty easy? All right, turn the page and let's talk about the next examples. You're going to perform the indicated operations with the given matrices. It's the same exact stuff, only your matrices are up here. So I'm going to show you how to write the first one, then I'm going to have you pause your video and try these. So A plus B simply tells you to write down A, then a plus sign, and then write down B. And then simply add them together. So pause the video, try all three of these examples, and we'll see how you did. All right, let's see how this addition went here. So 3 plus 1 is 4. Negative 1 plus 0 should have been negative 1. And 3 plus 3 should have been 6. And 2 plus negative 2 is 0. Hopefully you got that one right. This one, make sure you wrote it in the correct order. It is C first. So I'm going to copy down my C matrix, then minus, and then my B matrix. And then hopefully all you had to do was subtract them. 3 minus 1 is 2. Negative 2 minus 0 is negative 2. Negative 1 minus 3 is negative 4. And 4 minus negative 2, be careful there, is 6. And hopefully you got that one right. Let's look at the last one. There is a 3 and a 4. Those are scalars. So 3, and then A is this guy, plus 4, and then we got this guy. So what comes first, your multiplication or your addition? Hopefully you said multiplication. So let's do 3 times this first matrix. 3 times 3 is 9. 3 times negative 1 is negative 3. 3 times 3 is again 9. 3 times 2 is 6. Still got the plus sign. The other matrix, we're going to take 4 times everything in here. 4 times 3 is 12. 4 times negative 2 is negative 8. 4 times negative 1 is negative 4. And 4 times 4 is 16. Are we done with this problem? No. We still need to add to get our final answer. 9 plus 12 is 21. Negative 3 plus negative 8 is negative 11. 9 plus negative 4 is 5. And 6 plus 16 is 22. And hopefully you got that one right as well. So at this point you can stop your video and I'll see you in class.